Hi, this is Miss Park, and this video is about simplifying expressions. Before this video, we learned how to collect like terms. So an example of collecting like terms is if we have an algebraic expression made up of a bunch of terms. So let's take an x term, let's take a y term, maybe an x squared term, and then another x term. Okay, and collecting like terms is saying that if the variables have if the terms have the same variables and the same exponents on the variables, then we can actually add them up because they are objects that are the same. So 2x and another positive 7x, that's like two objects and then another 7 of the same object. 2 bananas plus 7 bananas. And so those two can be collected to be 9x. Now, the other ones, the y term and the x squared term, are not like terms of anything else because they have different variables or different exponent on the variable. So that was collecting like terms. The new thing is called distribution, and distribution is a multiplication. So we might have a number, and then you'll see a bracket, and it looks like this, stuff in the bracket. And what it means is that it's a multiplication. So in this case, multiplying 2 by everything in the bracket. Everything in the bracket is going to be times 2. So it's distributing this 2 into both terms. And sometimes the term that's being distributed also has a variable. So maybe we have something like this, negative 5x, and inside we have another x plus 1. Okay, this negative 5x will be multiplied by x, and the negative 5x will also be multiplied by 1. So I will show you some examples. Expand and simplify is combining the distribution and the collecting like terms. So I'll show you some examples. You'll get a complex looking statement, and then you will do the distribution, do that multiplication to get rid of brackets. That's the expand. So expand is get rid of brackets. And then once there are no more brackets, then you can simplify, which is the collect like terms. Okay, so in this video, I'm going to show you some examples from our booklet. Okay, so first things first, this is page 7 of the booklet. Doesn't matter if the page number is different, but this is the page. I'll do a few examples from here. So here's some simple ones, 3x times 5x. Okay, this one is not a distribution. This is just a straight up multiplication. When we see brackets, it's multiplication. We never use x for multiplication because it looks like the variable x. So all we do here, this is from our powers concept. When you have a term times another term, it's the multiply the coefficient. So 3 times 5. So multiply the number parts. And so you get 15. And then x times x is x squared. And I'll remind you, when we learned about powers, there is an invisible exponent 1 here and an invisible exponent 1 there. And when we multiply powers that have the same base, in this case x, we add the exponents. So that's why we have x squared. So that's one of the exponent laws. Okay, let's do another one. Let's do 1h. So 1h, negative 4 times 2, we deal with the number part first. That's negative 8. And now I have a t times a t squared. So the base is still a t. There's an invisible exponent 1 there. So t to the 1 times t to the 2 is t to the 3, or we say t cubed. Question 2a, so here's one where we have to expand or distribute this 5. Everything in the bracket is multiplied by 5. So it's 5 times x, and it's also 5 times positive 4. So what we do with that is we do the first multiplication, 5 times x is 5x, and then 5 times positive 4 is positive 20. And you'll notice there are no brackets in my answer because I have expanded it and lost the brackets. There's no more multiplication to do. Let's look at 2f. So 2f has a negative number in front. It doesn't matter. We're just going to distribute it to both of those terms. So we're going to do negative 4. I'm just going to write this extra step. You don't need to write it. This is extra. Negative 4 times 3x, and also negative 4 times negative 2. Okay, so I've distributed the negative 4. Negative 4 times 3x is negative 12x. Negative 4 times negative 2 is 4 times 2 is 8. Negative times negative is positive. Positive 8. Remember that rule only applies to multiplication and division. So be careful using it. All right, that's 2f. Let me take another one. Let's take one that's got maybe some exponent laws in it. How about this one? Let's take n. So we're going to distribute the 3a to both. 3a times a squared. Okay, so in front of the a squared, there's an invisible 1. There's a coefficient that is 1. So I have 3 times 1 for the number part, and then I have a to the invisible 1 times a squared for the a part. So that's a cubed. Then I have 3a times positive 7, and that's positive 21a. And that's it. I can't collect those like terms. I can't collect the like terms here because there are no like terms. There's an a and an a cubed, and they cannot be combined. All right, let's go a little bit harder here. So as we go down the page, we see there's more terms inside the bracket, but it doesn't matter. We're going to multiply. I'll take 3i. We'll multiply the term outside by everything inside. So there's going to be 3 different multiplications to do. So let me do this step by step. The first one is going to be 3s squared t times st. Then there's going to be plus 3s squared t times negative t cubed. And then there's plus 3s squared t times positive 1. Notice they're all pluses because this 3s squared t is a positive. It's a positive term. So when we're using the terms, we always have to include the sign. Okay, 3s squared t times st. So that's 3 times 1 because there's an invisible 1 in front of st. So that's 3. S's, I've got s squared times s. So that's s cubed. The t's, I have t to the 1 times t to the 1. So that's t squared. The next one, I have positive 3 times negative 1. So that's minus 3. S squared times, well, there's no s's in the bracket, so then that's just s squared. T times t cubed. So that's t with the invisible 1 times t cubed. So that's t to the 4th. And the last one is 3s squared t times positive 1. So that's just 3 times 1, which is 3, positive 3. And then the s squared t's, there's nothing to multiply them with, so they just sit there. And there's nothing I can do to collect like terms because there are no like terms. They're all s's and t's, but they have different exponents. So I don't have any 2 terms that have the same variable and the same exponent, so I'm done. Okay, now we do have other questions that can get a little bit harder where you'll expand and simplify. So that means you'll get rid of the brackets and collect the like terms. So let's do a question like that. I'm going to go to the next page. So this next practice page, you see it says, some of them say simplify and some of them say expand. Whenever there are brackets, it's going to say expand. Okay, that's expand. And then there is expand and simplify. So that's putting it together. So let's do one. I'll do one from question 5, expand and simplify. So let's do 5e. Okay, everything in front of the bracket is multiplied by everything inside the bracket. So 7 times 5x is 35x. 7 times positive 2y is positive 14y. Okay, we've expanded the first bracket. Now we're going to expand the second bracket. This number in front is negative. The negative goes with the term. So we have negative 3 times 8x. Negative 3 times 8 is negative 24. And now I have an x. And then I have negative 3 times negative 2y. Well, negative 3 times negative 2 is going to be a positive 6. And so I have positive 6y. Now I've done the expand part. Now I got to do the simplifying part. So I'm going to look for like terms. I see there's a 35x and a negative 24x. I see there's a positive 14y and a positive 6y. So now let's collect the x's. 35 minus 24 is going to be 11 x's. and 14 plus 6, and that's going to be 20y's. And that's it. I've done the expand and simplify. All right, and sometimes it'll get, let's see if I can find like a really challenging one. Well, you can try the challenging ones, right? They'll be here. Look at this one. Let's do one last one. Let's do question F. Take a look at question F. This one's probably it's got like a few things that could trip you up. Notice it says 3x squared minus 7x squared. Those are like terms, but we can't do this subtraction. We can't say that this is negative 4x squared because of order of operations. Remember BEDMAS, order of operations? We cannot do this subtraction over here because we must do division, brackets, exponents, division or multiplication and addition first. So I noticed that there are brackets. There's a 5x minus 3, but there's nothing I can do because they're not like terms. So the next thing I can do is this multiplication. So I'm going to do 3x squared is just going to sit there. We're not ready for it yet. And I'm going to expand this part. So negative 7x squared times 5x. So we got to go negative 7 times 5 is negative 35. And now I have x squared times x. That's x cubed. Negative 7x squared times negative 3. So that's negative 7 times negative 3, positive 21. X squared times no x's is just x squared. All right. Now I notice so I've done all the operations, I've expanded everything, but now I notice there is a 3x squared and a plus 21x squared. So those two are like terms, and now I can add them together. So this is 24x squared minus 35x cubed. And that's it. I can't do any more than that. All right, so please practice. There's lots of practice, and I can even give you more. The answers are in here, right here. The answers are at the end of those few expand and simplify pages. Okay, thank you for watching.